Hello viewers, welcome back to another section of my YouTube channel tutorial. In this video I have an applied electricity problem. This is an application of the superposition theorem as well as reciprocity. So please pay attention, watch the video to the end so that you understand how to solve such a problem. I have this circuit network here and it's a multiple source circuit. 120 volts here, 60 volts here. I have a current I2, then a number of resistors. Now the first question is find the value of I1 in the 120 volts if it is deactivated. So find the value of I1 if the 120 volts is deactivated. So this is a 120 volts. If it is deactivated, you have to find the value of I1. Now find the value of I2 if 120 volts is still deactivated. Then find the value of I1 if the two voltage sources are all in the circuit. This is a simple problem we have. Let's see how we can solve this. The first part is find the value of I1 if 120 volts is deactivated. So let's see. We are going to deactivate 120 volts by creating a short circuit since 120 volts is a voltage source. So I have my 6 ohm maintained and my 120 volts will be a short circuit. So I have this, then I have this, I have this here, then I have my, so I'll have my 60 volts here. So this is 60 volts. I have my 7 ohms. I have my 6 ohms this side. Then I have my I1 pointing this. I have my 3 ohm. Then I have my I2 pointing this side. I have my 6 ohm. Now to find my I1 when 120 is deactivated is simple. I1 happens to be the total current of this circuit. Hence I need my total resistance. Now how do I find my total resistance? We have to start from the point away from the source. So here and here, 6 and 6 here are in parallel. So you get 6 times 6 over 6 plus 6. That is 36 over what? 12. Giving me what? 3 ohms. So now I have simplified these two and I've got what? 3 ohms. And the 3 ohms will be in series with these 3 ohms. Being here. Here is my 6 ohms. Then my 7 to my 60. So this is my 60 volts. This is my 7 ohms. Then I have my I1 here. Then the I2 is still inside here. So let's see. 3 ohms here is now in series with what? My 3 ohms here. This 3 ohms. So this is 3 ohms. So 3 ohms will give me 6. So I'll get another 6 ohms. Then another 6 ohm here. Then it will finally move into the 7 ohm to my 60 like this. Then my I1 is here. So we are interested in the I1, that is why I'm not focusing in the I2. So once I get my I1 like this, right, we are going to get what? This and this to be in parallel. So 6 by 6. When you have two equal resistance in parallel, the effective is half of one magnitude. So it's automatically 3. So this becomes 3 ohm in series with what? Our 7 ohm. Then to our power source, which is what? 60 volts. Then this is the I1 we want. Hence, the total RT becomes what? 10 ohms. Then VT is what? 60 volts. So my I1 becomes 60 over 10, giving me 6 amperes. Sorry. So 6 amperes. And that is the value for I1. So first part solved. The second part is find the value of I2 when 120 is still deactivated. To find the value of I2, what you're going to do is, we know the value of I1 coming as what? 6 amperes. Upon reaching here, we have to combine the rest to use current division. So let's see. When we reach this side, so let me start from this side. So we are going to reverse what we did. I1 here is what? is 6 amperes. So the 6 ampere will pass through the 7 and it will pass through the 3. So to avoid any confusion, let me start from this side and do the simplification. So 6 ampere is coming. Now to apply current division rule, I should have only 2 branches existing. For that reason, I'll have to combine this and this, this and this to get only 2 branches. So now the 6 amperes has passed through this, so I'm not going to consider this. So I'm considering this 6 ohm and the rest. To combine the rest, I'll have this 6 ohm in parallel of this. That will give me 3 ohms, because we've already done it here. We had 3 ohms. Then the 3 ohm will be in series with this 3 ohm to give me what? 6 ohms, 6 ohm. So at this point, that is where I can find my what? Current passing through this 6 ohm by current division. I have 6 amperes, so since they are equal, I'll have 3 ampere going here, then what? 3 amperes coming here. So now I've got 3 amperes coming to this 6 ohm. And you know that this 6 ohm is a combination of this side to this side. For that reason, the current has been able to pass through this. So at this point, you realize that this whole combination was 6 ohm and the current passing through is what? 3 amperes. So the 3 amperes will pass through these 3 ohms which is direct in series. And finally, at this point, this is my I2. We apply our final current division. That is 6 and 6. So 6 on 6 plus 6 times the current passing through, which is 3 amperes, giving me half of 3, and that is what? 1.5 amperes. So 1.5 is what? I2, and that answers our second part. So the 1.5 is the one passing through the I2, because this 6 amperes will break down into 3, some will pass here, then the 3 2 upon reaching here will split into what? 1.5. Finally, find the value of I1 if the 2 voltage sources are all in circuit. This is a critical part of our problem. So at this point, I know that the contribution of this 60 volts is what? 1.5. Sorry, the contribution of this 60 volts here is what? Is producing 6 amperes in the I1. Now, what will be the contribution of 120 before I can conclude? To get a contribution of 120, I need not to pass through all these processes. I need to draw where 60 ohms is not there. For that reason, I need to deactivate the 60 volts. So see, I'll get my 6 ohm, my 120 volts. Then I'll get my 6 ohm, my 3, then this my 6 ohm, then this is the 7. So my 60 volts has been deactivated, so 7 ohms. Then I have my I1. This is what? 3 ohm, right? So this is my I2. So I'm to find my I1, but here I need not to go through the process, but I can use reciprocity to find the current I1 by making this thing here equal to what I have. For that reason, let's use reciprocity to bring this 60 volts here to this side. Once we bring the 60 volts to this side, the current in this branch will move to this side. And what is the current? I2, 1.5 amperes, right? So 1.5 will move there. So now let's see. I'll have my 60 volts switched to this part by reciprocity. Then it will go into what? My 6 ohm to go into my 3 ohm, coming down to my 6 ohm like this. Then at this point, my 7 ohm is here. Then I have my 1.5 ampere. So that's the current coming. From now, we can compare this to this. That if 60 volts produce 1.5 in this side, that is the I1. If the 60 volts is producing 1.5 because you have switched the position by reciprocity, then what will 120 produce? Hence, you know you are going to get 60 over 1. Sorry, if less, more divide, and if more, less divide. So now we want that of 120. 60 is producing 1.5. So 120 over 60 times 1.5 amperes. And that is going to give us what? 2 times 1.5, because this goes into itself 1. Go here 2. 2 times 1.5, and that is 3 amperes. So meaning the 120 volts will produce 3 amperes as I1, and the direction is what? Is this side. So you can see that I1 has two parts. The one by what? The 60 volts. So I1 by 60 volts moving up was what? 6 amperes from the initial question. From the initial question, it was what? This is it. Sorry. It was 6 amperes moving up. Now the 120 is moving in this direction and is producing what? 3 amperes in that direction. So I1 by 120 volts moving in the opposite direction is what? 3 amperes. Hence you are going to get 6 amperes minus 3 amperes, and that is going to give us 3 amperes for what? I1. So this is application of superposition as well as what? Reciprocity. Thank you for joining me in this video. Please subscribe, like, and share to support.